Hi, Tony. How are you? I've seen the paper. I've just went through it this morning and gone through with how I think it went. But what I'm going to do is I'm going to focus on paper two, obviously the prep for paper two. Just setting up for it to go live on TikTok as well. So is that ready to go? Just setting up now. So, what I want to go through today in today's session, what I'm going to do is basically just go through. Oh, 1 second, it's switching me to the TikTok studio. Right, if I go live, go live, go live, go live, go live. And then if I move that out the way. Let's got this over here. Module 4, questions usually application. Yeah, it can be with regards to module 4. I mean, module 4 is in a sense application. If you think about it, it's to do with the immune system, it's to do with classification, evolution. So it really just depends which way they want to go. Hi guys, if you're just joining me. So what I'm going to do is I've been through paper 1. I've also already had my predictions of what I think are I say predictions, I hate saying that word because I don't feel like I have a prediction as such. But what I'm going to do is I'm going to go through some questions which are not from your exam board, but I think are really key to where I see OCR going with the paper, and also to cover some content that you may actually be interested in revising. So I want to start with the first thing I want to look at is a question like this. So I do feel like if you were in my live last week, you'll know that I talked about the lacoperon, and I feel like the lacoperon is going to come up, or at least something to do with gene regulation. So this paper I found with this question I thought was really quite clever, because what they did is there is an assumption, if they give you a question like this, which they seem to be going down the route of, this is live right now. So I'm currently on YouTube and also on TikTok. So you can jump to whichever place you want to go, but I want to make sure that I am helping as much as I can. Would you say the first paper was more difficult? Do you think the second might be nicer? I wouldn't say the first paper was more difficult than ones that I've seen in the past. I've just been through the first paper myself and acted as if I was you guys. And so therefore, because I did that, I feel like there was a lot of application questions, but everything you needed to apply the knowledge to the paper was there. And also it did have some hard questions, don't get me wrong. There's a few that I'm like, oh, they might be asking this, they might be asking that I'm not sure on. And so I would definitely say that there are a few where I'm like, oh, and I can see why people have come out going, this is really hard. But I would say for that it's not any harder than last year's paper. I know everybody feels like it is, but it's not. It's just a different way in which they've asked the questions would be what I would say. But just coming back to this question here, if you get a question like this, so they've told you about the lacoperon in prokaryotes, and then they're asking you to describe the differences. So basically, everything you need to answer a question like this is in front of you in the question. They've shown you a whole load of information. Now, for those of you who are just joining me, this is not OCR, okay? This is not OCR. This has come from a different exam board, but I liked the question and I feel like it covers a lot of the content. In fact, I know it covers the content that they could ask you in other A levels. What they'll do is they'll just ask questions in a different way. So key thing to note then is, what are they telling us? That's important. The inactive repressor here. How can you access these slides? Have you Mariam, what do you want when you say how can you access the slides? Um, I, if you were a private tutee of mine, then you would get a copy of all resources. But with regards to these lives, I don't actually put them forward because they're just how I feel at the time when I'm doing them. Um, Anyway, let me keep going with how to answer this question. So when you get a question like this, and this is something I saw in paper one, that they'd given you some hints in the questions, you have to be able to pull out of those hints. So look for the hints, dissect the diagrams, dissect the graphs, dissect the information that you have been given. Yes, you'll be able to rewatch these later, guys. That's why I'm doing it on here because they save automatically. So you just need to watch the live. How do we need to, what do you need to know about bioremediation? Not really much about the bioremediation, Amy. They removed that out of the specification as a named one to know. If they're going to ask a question about it, it will be in there with some information. But the key thing is bio is life. And so we're talking about microorganisms being useful. Microorganisms with medicine, I do feel like could come through, linking it to, and I'll look at this in a minute, but linking it to the fermenters and genetic engineering. I feel like there's something coming about those together. Oh, where's the question from? The question that I'm looking at right now is actually an international A level. So it's CIE's international A levels. Right, okay. What times days are you doing these lives? Depends, Lucy. It basically is I've sat and done paper one this morning. I've then done a little bit of planning for you guys of this, and then it's when I'm free and when I don't have my clients. Wednesday is a busy day for me, so I definitely won't be doing it on Wednesday, but I will jump on at night when I can and whenever I can offer. Hi, Chidimam, nice to see you. Right, coming back to this question then. We have an inactive repressor. Because we've got an inactive repressor, what we have is RNA polymerase is able to bind at the promoter. So you should know with a lacoperon, RNA polymerase always binds at the promoter, and then it works its way down and is able to transcribe these structural genes. So this diagram is showing you that actually this regulatory gene isn't producing an active repressor, it's producing an inactive repressor. So this is where you curveball, you memorize the lacoperon and they give you a question which is assessing your understanding of lacoperon on different example. So that's where I would say to you, just be aware that there is always detailed terms. So just double check that you're not writing. Oh, there we go. That you're not writing the wrong information. Okay, so carrying on with this, what can we see? Right, well, we're seeing here that we've got a molecule which is called tryptophan. So tryptophan is going to go into the inactive repressor and activate it. In this case, an active repressor is able to bind to the promoter. So that's a way in which they could look at how there is a understanding of the lacoperon and then how you've actually applied it to the situation. So do make sure you're going through. And what they could also do is they could ask questions like, well, suggest why there is these operons. How does the environment affect gene expression? Well, the environment, if you're talking about the environment for the lacoperon, the environment would be the concentration of lactose and concentration of glucose. So what you have is some form of stimuli. The environmental conditions have changed. Therefore, they may need to switch on genes that were originally switched off, or in this case, opposite way around, they need to switch off the genes. And so that they are switching off the genes because there's no transcription occurring. when there is an environmental signal that they should switch off the genes. So it really just depends what example they give you as to how they want you to answer it. Um, Hormone concentrations, Aisha. So hormone concentration is going to, yes, count as the environment. So if the hormone is present in the environment, that hormone is then going to signal for something to happen inside. So if it's a steroid hormone, so interestingly, hormones came up in paper one quite a bit, but mainly through your multiple choice section. But it was asking, did you know about the adrenal gland, for example, and aldosterone? So there are definitely parts where it's application based, but it is also important that you note that the environment that we're talking about. So right now I'm sitting in my room, and in this room, I have the environment which has carbon dioxide concentration, which is going to increase the more I talk. The more I talk, the more I'm going to be doing respiration. So the oxygen concentration will decrease. Obviously, if the environmental temperature is hot, I'm therefore going to be feeling that in the fact that I don't have my cardigan on. So when we talk about the environment, we're talking about the abiotic factors and how those abiotic factors, or linking back to your question about hormones, those hormones are about the concentrations. And as that concentration increases, that will have an effect. If that concentration decreases, that will also have an effect. So your blood glucose levels, for example, are going to cause the secretion of insulin if they get too high, or if they get too low, cause the secretion of glucagon. But that's paper one. I want to come back to paper two. Can they ask module 2, 3 topics in paper 2? Absolutely, paper module 2, not module 3. So module 1, 2, let me get this right, 4 and 6. I always want to say 3 for some reason, because in my head biodiversity should be the third one. 1, 2, 4, and 6, anything about them together will be potentially asked. So because it's not on the promoter, there's no transcription. No, remember the repressor protein is going to bind to the operator. So this is important. You note the difference. If we're talking about the lacoperon or we're talking about this one, the repressor protein binds to the operator. Because the RNA polymerase cannot bind to the promoter, transcription cannot occur. So it's really important that you're talking about the RNA polymerase is not able to bind to the promoter. Therefore, there is no transcription. And if it does the repressor protein bind to the operator or the promoter? So the repressor protein is going to repress and therefore prevent transcription from occurring. So if they haven't told you and you're not sure, what you want to do is you want to give them what you know. A repressor protein is going to prevent transcription from occurring. And that's where you want to go. So in this case, why the structural genes in operons are transcribed together, there's one promoter. So instead of you having many genes with many promoters, there's one promoter. And also because all of these proteins, whatever these proteins are going to work together. So when we look at the lacoperon, we have our lac Z, lac Y, lac A. We need to be able to hydrolyze the lactose. We need to be able to bring it in because of permease. And we also need to do transacetylase. We need to change one of the amino acids. Sorry, we need to change one of the monosaccharides, the galactose, into a form which is easier to enter the respiration pathway. So it's important to note that when you are going through this, that you understand that structural genes are going to all be working together. And that's why with prokaryotes, what they will do is they will have these operons. The operon is where there's one promoter and these structural genes are all transcribed together. So the mRNA is produced together because it happens simultaneously. Transcription, translation happens simultaneously in prokaryotes because their DNA, and Tony, this brings us back to module 2, because We know that prokaryotes' DNA is inside the nucleoid or the cytoplasm. In your exam, just write cytoplasm. Because that DNA, that circular DNA, is inside the cytoplasm alongside the ribosomes, it therefore happens simultaneously. Transcription, translation, as soon as something is transcribed, translation can start to occur as long as that mRNA strand is attaching to the small subunit. So because you've got that together, you understand that these are prokaryotes, these are small organisms which can do the transcription translation because they have the genetic material, because they have the ribosomes. Isn't operator only found in bacteria? No, it's not only found in bacteria, but it's more common because they're more simplified. So when we talk about it with regards to the what am I trying to say to you? When we're talking about it with the eukaryotes, we don't say operon because we then talk about the transcription factors. Just one last thing, because someone asked about the difference between the structural genes and the regulatory genes. What's the difference between the functions? Your structural genes, you should know that they're going to code for some form of enzyme. They're going to code for some form of a structural protein. So if we're talking about collagen, for example, collagen is required for your blood vessels. Yes, I am going to initiation because I have a feeling that there's going to be something about natural selection, evolution, and maybe speciation, whichever direction they want to go on that one. But it is coming. If I don't manage to do it today, then I will definitely do it in my next sessions that I do this on. So yeah, so structure. Unmute, need to mute myself. Should hopefully bring me back in a second. Oh, right, where are you going? I think I've killed YouTube on here. Either that or my computer's killed. Right, what are you doing? Okay, going back. Oh, go away. Where it's so difficult because I've got too many screens open at the moment. But on my computer is just having a bit of a hissy fit on what it wants to be able to see. Right, put you back in there. And let me just double check if that's now working. No, you're still not working. What's going on? Well, that's really not good. Okay, I'm going to keep going. And the only problem is TikTok doesn't save it as much as the YouTube does, which is really frustrating. So the video won't be available for anyone later on. I know people are currently studying for their chemistry exam. I wanted this to be available for people for when they're not focused on chemistry. So let me just see.